Hey guys, so I am going to show you how to do this problem on the Ed puzzle. That way, if you had any questions about it, we could go through. We've got 2x minus 7 on the left, and on the right side of the equation is 8x minus 47 minus 3x minus 14, all divided by 2. Anytime you see a complex equation like this, and it includes a fraction, you got to get rid of the fraction. Like, your first step should always be to dump a fraction. And the way that you get rid of a fraction is just doing the inverse. We're dividing this whole thing by 2. So the opposite of dividing by 2 is multiplying by 2, right? So we're just using a flat out inverse operation. And instead of dividing by 2, we're multiplying by 2. But that means we have to do the same thing on both sides. And it can't just be a single term. We're multiplying each side by 2, the entire side. When you multiply through on a side, you can't just apply it to a single term, okay? So let's cancel that out. That gets rid of our division. And I am left with, and I'm just going to go ahead and distribute this now because, well, it's easier. 2x times 2 is given 4x minus 14 is equal to, now this is gone, remember, 8x minus 47 minus 3x minus 14, and the 2 is disappeared. So next step, I need to simplify wherever I can. And it looks like I can simplify with this negative sign in front of a parentheses. Remember that a negative in front of the parentheses means that we are subtracting this entire set. So everything in here has to be applied to a negative. It's as if we're multiplying by a -1, right? But when we apply this negative to both sides, or to both of the terms inside the parentheses, it doesn't leave it without a sign here. It's still separate, so it's going to become a plus. So this actually becomes plus, so 4x minus 14 equals 8x minus 47, and then this minus sign, when it's applied over here, becomes a plus. Negative 3x plus 14, because we're reversing the signs, okay? So I could have just left this as a minus, but I wanted to demonstrate that that's how you needed to make sure that you get rid of that. So from here, I'm going to continue simplifying by combining like terms. And I have a group of 8x's and negative 3x's. So the left remains the same, but 8x's and negative 3x's is going to give us our lovely 5x's. So I have canceled out my variables, but I still can combine. I can still combine my constants. So I'm going to combine my two constants, okay, and I'm going to be left with a minus or negative 33. All right, so now we've gotten down to this point. We're in really good shape, actually. The only difficulty is we have to make sure that we only have one group of variables. You can't just have two groups of variables, one on each side. In order to solve for x, we need to make sure that we have a single group of x's all together in one place. Now, to do that, you can't multiply through by a number of x's. That won't cancel one of them out. It just increases the index. We're literally removing it, and when you think of removing something, you should think of subtraction, right? To get rid of something or to remove is to subtract. So I have a positive 4x. I'm going to get rid of that by subtracting 4x's on both sides. And I took you could use the 4x or the 5x. Honestly, it does not matter. However, I like to use the 4x because it's going to leave me with a positive x on the other side. So this cancels out, leaving me with negative 14 on the left, 1x minus 33 on the right. So last step is simply to isolate the variable by adding 33 to both sides. cancels that out and isolates my variable such that I have 19 is equal to x, or x is equal to 19. Oh, I went way off the page there, but you know how to isolate a variable by getting rid of a negative x. So if you have any questions about that, let me know. Remember that the important steps here are to always eliminate the denominator first by multiplying through by a common denominator, distributing a negative, combining like terms, and then ensuring that you have one single group of x's. Thanks.